the next thing that we're going to talk about is symmetry. Symmetry is talking about a sort of balance that we have in our graphs. And so the first type of symmetry that we're going to talk about is symmetry with respect to the x-axis. A graph that has symmetry with respect to the x-axis is symmetric or reflected over the x-axis. Graphically, we know that this is our x-axis right here. So whatever we're going to draw above the x-axis, we will have the mirror image below the x-axis. For example, if I go up here, let's see how well I can draw this. The mirror image will come down below. Been close enough. And you can see that every point here, let's call a point here x, y, that there will be a mirrored point which is x comma negative y. That's for every single point along here. It doesn't matter which point you choose. Just change the y from positive to negative or negative to positive and you'll get another point on the graph. So if I were to numerically or tabularly look at this, we could say, let's say that's negative 3, negative 2, negative 1, 0, 1. So at negative 3 it's 0. Let's say at negative 2 it's, well, it would be positive and negative 1. There would be two values, up and down, a positive value and a negative value. At negative 1, let's say that is plus or minus 2. At 0, let's say plus or minus 2.5, and a 1 plus or minus 2.75. I am totally making these up, but the key here are the plus and minus values. We see that each x value has two function values. So what we see here is that these are not functions. They fail the vertical line test, VLT. But what we can say about it, and I said this already, is that if x and y is on the graph, we know that x comma negative y is on the graph. For example, if I know 1 comma 2 is on the graph, then I know that 1 comma negative 2 is on the graph. Or if I know that, say, 3 comma negative 5 is on the graph, then I know that 3 comma 5 is also on the graph. So it goes both ways. Alright, so the next type of symmetry we're going to talk about is going to be symmetry with respect to the y-axis. So again, this is symmetric or reflected over the y-axis. Again, graphically, I'm going to find my y-axis, and I know that it's going to be a mirror image over this y-axis. So I could do something like this. This, pretty good drawing, is a graph of the function that is symmetric over the y-axis. It's a mirror. So for every point x comma y, I know that I'm going to have negative x comma y is going to be another point. Looking at the table, x and f of x, I could do negative 3, negative 2, negative 1, 0, 1, 2. Let's say this starts at 1, 0, negative 1, negative 2, 1, 0. You'll notice that there are pairs here. The negative 2, 0 and the 2, 0 are together. We have our negative 1, that shouldn't be negative. This should, oh, there's a mistake. This should be negative. Okay? So the f of x value should be the same, but the x value changes. So algebraically, we say for all x values in the domain, we know that f of x is going to be equal to f of negative x. Another way of saying that is that if I have a point x, y, I know that there must also be a negative x, y point. Negative 3 comma 1 tells me I'm also going to have 3 comma 1 in there. We have another name for them. They're called even functions. These are functions. They're called even functions because functions in the form x to the n, where n is even, are all symmetric to the y-axis. Let me just circle this in a slightly different color. Talk about another name, another vocab term that we'll be using. Alrighty. Now the last one is symmetry with respect to the origin. Again, we're going to have something that is symmetric or reflected over the origin. That's kind of strange because now we have a mirror image or a reflection over a point. That's difficult to do. How do we do that? Well, we have our point here, that's our origin, which means any point I have, any x, y, will also have, if I reflect it directly over, same distance, we'll have a negative x, negative y. So here I have a function like this. Algebraically, let's say negative 3, negative 8, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, 1, 2, 4, 3, 8. Running out of room here. But you can see that there's a pattern. And algebraically, for all x values in the domain, we notice something about our function values. We know that f of negative x is actually equal to negative f of x. How do I see that? Well, negative 8, negative 3 changes to 3 comma 8. Or if I have an x and y, that's going to relate to a negative x, negative y. I can flip both the x and the y and get the same value. We have a special name for this. We call them odd functions because functions f of x equals x to the n when n is odd, again, are going to have origin symmetry. Alright, so that's our symmetry lesson.